Welcome back. Many of us are still waiting for those flying cars we were promised would happen in the year 2000. We also thought we'd have a robot maid, dinners that would cook themselves, and that we'd be living like the Jetsons. Well, we're not quite there, but we are getting closer to having a home that runs itself. In this segment, we'll discuss what is making ordinary home products smarter, something called embedded systems. And here to discuss the present and future of these smart products are Neil Gershenfeld, professor at the MIT Media Lab. He's also the director of the Digital DNA Laboratory there. And also with us is Glen Cunningham, Chief Technology Officer of Thalia Products. I'd like to thank you both for joining us here today. Neil, start out with a simplified explanation of what an embedded system is, please.
Well, for all the hype, the World Wide Web touches a subset of human experience spent alone hunched over typing on a computer. And that's a very small fraction of our life. Right now, we have to come to the computers on their terms. And in fact, they're not very smart. They're blind, deaf, and dumb boxes. Embedded systems is about making computers smart by bringing them where we go, solving our problems. So for example, right now, even just to travel with a computer, you need to carry lots of gadgets. We've developed technologies to take processors and literally sew threads to them and weave it into fabric. So something like a computer can be seamlessly, literally, woven into your fabric rather than having to carry the technology around.
And invisible.
And invisible.
Mm-hmm. You're the director of the Digital DNA Lab. What is digital DNA?
Chips.
Chips. That's brief. Elaborate a little bit, please. Thank you. What is digital DNA?
Digital DNA means the lightweight processing at the tendrils of the network. We spent billions of dollars developing chips that we put in dumb boxes that haven't changed from the earliest days of computing. So digital DNA is enabling intelligence all around us by embedding processors in them. Now that starts just simply as a chip, but it really grows ultimately into the deepest question of machine intelligence about how lots of little elements can collectively work together to solve problems.
Good. Okay, let's take a look at this report, which will give us one use, or a look at one use of these embedded systems.
Identix Technology in Sunnyvale, California, has developed a broad range of identification systems using the one authentication method that can't be altered, duplicated, or tampered with in any way, the human finger.
Well, we don't actually take the fingerprint itself. What we do is we place the finger on the sensor and take a digital photograph of the finger. When the individual places their finger on the sensor, the Motorola chip grabs that image and the Identix software extracts the unique information so we can accurately determine whether that person should be given access to the computer. If they're the right person, they're given access. If they're the wrong person, then we prevent them from getting into the computer.
The partnership between Motorola's chip solution and Identix Optics has enabled Identix to drastically shrink the scanner size.
5 years ago, this was the size of the technology that does what we were showing here. 3 years ago, it was reduced to this size. And now, with the semiconductor technology from Motorola and the optics design from Identix, this is the size that we're at, and this opens up entirely new markets.
The shrinking of the chip has also dramatically affected the price as well.
10 years ago, readers were thousands, tens of thousands of dollars, and they still are today in certain market categories. But in the commercial market, we've gone from thousands of dollars to a few $100s to 15 months ago to $20. And now we've reduced the size again from 1 inch to 3 millimeters and reduced the cost even now into the teens of dollars. Our goal was to drive the cost virtually out of this device completely.
Assuring the fact that this Motorola digital DNA technology will become an intricate part of your everyday life.
Wherever you are required to present some form of identification or some form of token to open anything from a door to a car to a PC to commerce transactions where positive identification are required. That is the scale and scope of what this technology can provide.
From Sunnyvale, California, this is Bill Rafferty reporting for The Next Wave.
So pretty soon, no car keys, no house keys, all of that is gone. How soon do you think?
Oh, today. This technology is leaking out. It's perhaps the biggest revolution yet in computing, but because it's seamless, you really don't notice it.
Glenn, your company focuses on a technology that makes smart appliances capable of talking to each other. Give us an idea of what that's about.
Well, for example, we will be making an alarm clock that will come out at the beginning of next year that can talk to any of the appliances in your home that are HLT enabled. HLT stands for Home Linking Technology.
What kind of linking is involved? Is it hardwire? Is it wireless? Or
both. If the appliance plugs into the wall, then it talks through its plug. So it talks through the house wiring. So it'll work in any home without rewiring your home. And if it runs on batteries like a smoke alarm, then it would send through wireless RF transmission.
and what will these machines be saying to each other?
Well, it depends
Turn
on
off, turn on, start, stop?
a little more complicated than that. For example, when the smoke alarm goes off, it will wake you up in the middle of the night through your alarm clock, and on a small display section of the alarm clock, it will tell you which alarm in the house it is and where it's coming from, so you know which door to run out. In the morning, when the alarm clock goes off, it will tell your coffee maker to start brewing and maybe turn on your curling iron and start your bread maker.
Let's take a look at this report, which shows us how some of these smart appliances will work.
Setting your alarm clock takes on a whole new meaning with Thalia's new line of HLT or home linking technology smart products.
It's going to tell your coffee pot when to turn on in the morning based on when you want to get up. It's going to say when your electric blanket should turn off and on. It's going to help with your home security, set up your house so that it'll be that one touch point within the home to control all these other devices.
Thalia will license the technology and marketing for products that talk to each other to companies like Sunbeam. Company executives say their clocks, coffee pots, and kitchen consoles will make consumers' lives easier and safer at an affordable price.
Why not have HLT if it doesn't cost you anymore? And that was done because virtually all of our products today have some form of microchip in them. So it was really just a question of converting to an HLT microchip.
This easy-to-use kitchen console has a spill-proof touchscreen command center which holds family memos and important phone numbers. In addition to downloading coupons and weather reports, it makes having and doubling recipes a snap. The alarm clock by your bed activates your coffee maker, reminding you when you've forgotten the water, and alerts you when and where your smoke detectors go off in the house.
As soon as the appliances can talk to one another, now they can start interacting and delivering services to one another, not only device to device, but also services from the internet.
Just plug HLT appliances in, no computer or special wiring needed. HLT integrates hardware and software, along with power line communication technology and radio frequency. These products are coming to stores next year. Future HLT products can improve health care, allowing patients to take their own blood pressure at home and send results to the doctor over the internet. Practical magic, making life for the consumer a little easier. In Boca Raton, Florida, this is Monica Paris reporting for The Next Wave.
Glenn, what's the technology change that's making it possible for these appliances to talk to each other?
Well, the technology's been there all along. One of the big things that's happened is that it's become inexpensive enough to do. As you saw in the videos, the chips have shrunk down and become less expensive. But in embedded systems, there have been chips around that you don't see for years. Coffee makers for years have been run by a chip that displays the time and sets the timer and so on. So it doesn't take a lot to add some software and some additional hardware to make that communicate to other embedded systems throughout the home.
Mm-hmm. And Neil, you brought some items here that literally cost pennies.
Right. You might not think of a penny as important for computing, but in many ways this is the biggest question of all in computation. If you think about information technology as a pyramid of cost, up top are big supercomputers and mainframes. In the middle are PCs you hear so much about. Then maybe cell phones, and it stops around there, around $1 or so. I think the question I get asked most is how to compute for 1 cent. And the reason is we're surrounded by trillions of things that cost a penny. And a great example is healthcare. As people get older, they have trouble managing their medication and they end up in hospitals and nursing homes. The numbers for the cost of that...
Because they forget to take it or overdose? Or
That's right. The medication is complex and their ability to follow the instructions is not as complex. Right. The cost of the healthcare system is a number like $100 billion. It's perhaps the biggest social, biggest economic problem in healthcare. But a pill bottle costs 1 penny. So adding more than 1 cent to the pill bottle destroys the business model and it doesn't work. So this is an example of how to compute for a penny. Working with Motorola, we're developing ultra-low-cost tags using both silicon chips and materials beyond silicon. So here are just 2 cards that have a special material built into it. And here's a little reader that's like a Motorola cell phone, but it sweeps the radio frequency spectrum looking for materials. And so if I turn it on, you'll see that it can recognize this card, and it makes that noise. That's how it gets excited, and this card makes that noise. So what it's doing is it's extracting an ID from these cards. That alone isn't remarkable. What's remarkable is literally there's just 1 cent added to this and a few dollars to that.
And if I'm an elderly patient dealing with the complexities of various kinds of medication and a program that I'm having difficulty following, how will this help me?
So then what happens is this thing connects directly to the internet. So first of all, your doctor can keep track of it. Well, the very first thing it does is instead of you having to read the pill bottle, the way this is being packaged, the pill bottle will glow. You walk into the bathroom and the pill bottle can just flash
When
and
it's
say,
time to take that medication,
So right, that's the very first
you'll
step.
get a signal.
That's right. Instead of reading it, it just says, come over here and take that. The second step is through the internet connectivity. It can tell your doctor, are you managing your medication? It can tell your pharmacist, do you need more of your medication? It can tell your children or grandchildren, do you need to be supervised? So something as simple as a 1 cent tag ultimately means quality of life for older people, and to get to 1 cent is actually one of the hardest, most fundamental research questions in all of electronics right now.
What's the effect on the lifestyle going to be, Glenn?
Well, this has interesting implications in the kitchen as well. This can be applied to any of the food items that you would buy at the store. So when you come home with your groceries, you can pass them by a scanner like this as you put them in the fridge or the cupboard, and your kitchen can now start keeping
So obviously we're
inventory.
not talking about a refrigerator that will tell you or tell your grocer that you're out of peanut butter and it's time to deliver some.
Oh, it may.
Oh, think about, I'd really underscore that. E-commerce right now, once again, means hunched over in front of a computer, clicking, saying, I want milk. I don't grow as a human being by telling the computer I want milk. But if your milk bottle has this built into it, the refrigerator can order the milk for me. So I just order the stuff that really needs me, if I'm going to cook for friends, not just stocking groceries. And there's still one more implication. If your consumer goods, your milk bottle has it, when it gets to the trash can, it can tell the trash can how to recycle it.
Great. Glenn, what are some of the appliances for the future?
Well, one of the things that we're concentrating on is just transforming the appliances that you're already used to using. So you're already inviting alarm clocks into your home and washing machines and dryers and so on. So we're making them a bit more intelligent so that you can access them from outside of the home, so that they can talk to each other, so that they can go out and say, I need more dishwasher
So we're coming to the
detergent.
point where a housewife who forgets to turn on the washing machine could call home and do it by phone.
Right. Or if she forgets to turn the iron off, she can call and make sure that it's off.
How far away is that, do you think?
Beginning of next year.
That's
So.
sooner than I expected. I
Yes.
thought you'd say another 2, 3, 5 years. Next year.
Next year. One of the things that we found in our consumer research and focus groups has been very surprising. We get prepared to explain the technology to the people and all the implications of it. It turns out that they explain it to us. They've been waiting for this and expecting it for a long time. So consumers know that this is coming, and they're just wondering why somebody
So
hasn't
there's a
done it.
very easy acceptance then.
Yes, much easier than we thought.
Gentlemen, I thank you both for being here. It's really been interesting. Some wise person once said the future is where we're all going to live, and these future products are so exciting for all of us. I wish we had a lot more time. Thank you both for being here. Glen Cunningham of Thalia and Neil Gershenfeld of the MIT Media Lab, thanks for being here with us and speaking with us today. I'm Leonard Nimoy. Please join us again to watch the future unfold on The Next Wave.
A portion of this series is sponsored by eBusiness Advisor Magazine and Conference, the guide to success in the new world of e-business, www.advisor.com. For more information on the topics discussed on this and other episodes of The Next Wave, please visit our website at www.nextwavetv.com.